Can anyone hear me online?
I can hear you, Nick.
Okay. Great. Okay, well, welcome. We just start with a little slideshow of things that we use to assemble the CubeSat and the CubeSat itself. And let's see, we could ask certain students to narrate it if they want. And then at 1:44, the live link at SpaceX will start. And then there's the launch. And then there's after we're up into orbit, there's a small delay because it takes about 50 minutes to position the spacecraft to the region where they want. Then there's deployment. We are number 11th to deploy today out of the 45 spacecrafts. For those of you that are here in person, have a donut. We bought donuts, or I bought donuts. I mean, the two things you need to stay up, sugar and caffeine, right? There are donuts. If you like original Krispy Kremes, there's those, and if for strawberries, there's those. Alrighty. So have a donut. Chocolate is great. Chocolate. Okay. I have no idea how many people are coming. We've invited the whole university. So let's wait and see. We got yeah, some are like that. Have a donut. Hmm. Oh, and they opened the door for us. That's great. I appreciate that. Hey, Jonathan. Narrate some slides. No.
Oh, well, narrating, this is easy. That's my graduation picture. Here's the lab. I think this is actually before we had the water damage. There's a group picture from 3 years ago. That was the trip we took to Paris. That was a lot of fun. Three of us from the project. I suppose at the time, two of us from the project and one of us former from the project went to Paris. But we've been doing all of this work for the CubeSat's been about 5 years now. Yeah, 2022. So 3 years of dedicated CubeSat, 4 years of dedicated CubeSat, but we've been doing some groundwork for that for quite a while, and it's exciting. Uh, I drove all the way from Iowa just to watch a rocket go up on a video.
And deploy in space.
Yeah,
Yeah,
that too.
sitting in, you're going to go see it kick that, and it's going to go flying by itself.
Hmm.
And you're going to say, oh, God, that's our poor little CubeSat.
It's exciting. It's fun watching all of these pictures, remembering, this is a fun picture. That one was the mission patch designed by local middle schoolers,
High schoolers.
high schoolers. Um, but it's been a long journey, and in what, half an hour, we'll get to see the rocket go up.
1:59. It's on time.
Ah, it's that's exciting.
I'm impressed with that last picture. We're trying to control the mass of this spacecraft. And every gram counts. What did someone do? They slapped a property sticker on it. Like someone's gonna go up there and check it every now and then. Yeah.
That just reminds me of the first meeting we had with Nanoavionics, where they were talking about how heavy do you think your payload's going to be? And we're like, oh, 4 or 5 kilograms. And the engineers just stared at us and was like, huh? You're going to do what? What's your pointing requirement?
3 kilograms to live it. Now
Right.
fine of it.
What's your pointing requirement? Oh, 360 degrees. So I suppose for those of you in the room who don't know, I'm John Folkerts. I graduated in December with a PhD. I've been with the project for about 7 years before that, doing various things. I predate the CubeSat, and we've done a lot of really cool, really good science. Yeah, this last December, got my PhD.
Printed my thesis in goodness sakes alive. It was October. It was October, yeah, it was October. Yeah.
Oh, Neutrino Alley was so much fun to visit.
It's changed in size. Sometimes it's big, sometimes it's small. Worked on this project. Undergraduates, PhD students, aerospace, physics, all sorts of experience. Brian can tell us more about the integration of that. Oh, the CubeSat patch, yeah, it was a contest. Her name is Ryan.
Yeah, I was a little sad yesterday. I drove to visit my friend in Casey before coming down to Wichita today, and about an hour out of Iowa, I realized I had forgotten to bring my remove before flight shot glass. So we'll have to live without that.
Follow it sometimes, then it gets bigger.
Hmm. Mostly bigger over time, bigger and better.
CubeSat,
Oh, I remember those integration days. Those were so stressful.
oh,
The the second most stressful day of my life so far was watching Holger do the rocket surgery for the kill switch. Oh, I can believe how stressful that was. The most stressful day was when I did the burn wires for the shake test. I was just thinking the other day that, oh, I'm not there anymore. They have to completely relearn how to tie those burn wires. Wait a second. That's not how math works.
you can say we're launching in 5 minutes after.
So, Brian, what was the most stressful part of the project for you? Was the burn wires? Yeah, I can believe that. Oh yeah, doing those for the shake test was super stressful.
I had to take like an actual break.
Oh yeah. When Holger and I were working on the wires for the shake test, there was I don't know, 40 minutes in where I just said, let's take an hour. Let's take a break. I need to calm down. Oh no.
Other than that,
Oh, I was about to say Paris. Uh Well, discounting Paris, I think for me the most fun was just doing a lot of the lab development, working in the labs. Just was fun, getting to experiment and mess around with stuff and track down ground loops, even though it's a little annoying, is a lot of fun. What was your favorite part, Brian?
I don't know, maybe planning the ground mission with the radio, finding a way to implement an automated like timestamp file into automated radio contacts that then downloaded files and changed the satellite's operating plan. Really like seeing all these different mission planning parts coming together independently. It's like solving a puzzle with all the different pieces that you know fit, but you haven't fit them together before all at once. And as you know, integrating the parts into the satellite, you can't always guarantee the puzzle pieces always fit together all in one cohesive piece, even if they fit together in individual components, both physically and, like planning wise.
What time is the first contact supposed to be?
Okay, so we're still working on that, unfortunately, but the moment we have a booked contact with Leaf Space will be then, and we have to integrate, or sorry, well, I don't know if integrate is the right word, I used that already. We have to put the information from Leaf Space and how the radio works. I have to put that into Nano MCS's mission control software, and then that will allow us to write control files that will initiate radio contacts. So those are two pieces that I haven't fit together yet, but I've seen the form of them. But I haven't actually like dealt with the S-band radio, which is probably very stressful in itself. I've only worked with the one of the two radios, the UHF radio. Um, So that's one actually untested piece that we have to assume we have to go through the documentation for and assume we did it right. That's another stressful thing too. I could rant about all the incredibly dense documentation that I had to read and understand for this project, from NASA to the nano avionics to Leaf Space, all to the Sat Lab radio, all the different documentations that you have to fit together. It's satisfying, but it's also pretty stressful, and sometimes documentations are wrong, as Edward would know the most. That just working around incorrect documentation has to be its own skill you can put on a resume.
So, Daniel, most stressful, most enjoyable.
Most stressful, most enjoyable. Let's see.
I think my most stressful moment was probably filling out the epoxy for the shielding. That was a lot of fun. We had to measure things, or we had to measure the tungsten or the tungsten powder so that we could have a density. Was it 3.5 grams per cubic centimeter, I think. And then after we mixed it, we had to vacuum it. And after we vacuumed it, we had to put it in the mold, wait. That wasn't too much fun. I think that was for me the most stressful part, but I'm also a lowly undergrad, so I didn't get tasked with the actual stressful stuff. So
And most fun.
yeah, I get all the fun stuff. But I think my favorite part of being on this project was when I was able to finally reconstruct the energy spectrum for these simulations. That was about a year and a half of ridiculous simulations and teaching myself numerical linear algebra. It's a whole lot of goofing around, but it sure did feel nice to finally see it work out. So I think that was my favorite part. Edward, how about you?
Stressful, most fun.
Yeah, most stressful.
I'd probably, I'd probably say the most stressful part was, as Brian said, working around incorrect documentation. Sometimes things just don't quite work out the way that you hope they do. But the fun part is honestly sending up a satellite in space. It's a great honor to be part of this project.
All right, this is Holger Meyer. I think the most stressful part was yet another piece of paperwork after you thought all the paperwork was done, and then yet another piece of paperwork after that, um, and not knowing how many more pieces of paperwork there would be. Yes, right. So, the, yeah, right. Yeah, repeating what Nick just said. After we did all the paperwork, there was an email. Yeah, you don't have a way to steer the spacecraft. So if you hit anything, you are responsible. Yeah. There.
The ISS. They pushed it out, but they didn't push it out so hard. It hit off the spacecraft, then hit off the solar panels of the ISS, killing one of them, going on its way into space. It's like, just at launch, you scratch the paint off.
And stuff like that happens. And it's nice when silly things like that happen, because that's how you know it's become routine to do these things. So no, for us, none of this is routine. For us, it's the first time doing this. And so for me, the most fun part is always doing anything for the first time and then finishing it. So, talking the last screw on that spacecraft frame when we did the last assembly, and all those steps when it's really coming together, those are the fun moments for me. So, anybody else?
I just want to add that I am so glad that for most of the assembly, I was the one with the camera, so I didn't have to be the one touching the CubeSat. It was someone else's fault if I was just taking pictures. Oh yeah, trying to find the right picture. I was so sad the other day. I was looking for pictures of me and the CubeSat, and at least on my phone, I have no pictures of me with the CubeSat because it's always other people. So, let's see. Well, we've gone through all the people who were recently on the project. Caleb, most fun, most stressful.
Yeah. Okay. To introduce myself, my name's Dr. Caleb Guimar. I was on the project in the very early days. So I actually did some of the numerical simulations of the spacecraft concept. And at that time, it wasn't immediately clear, if something like this could actually be feasible, using this veto array method to detect cosmic ray events and other background radiation events and clear those out while maybe being able to detect neutrino events. So what I was doing for my master's degree research here was doing those numerical simulations. And I'd say the most stressful part of this was I remember there was a point in the code development where I had something, and if I remember correctly, it was the frequency of galactic cosmic rays, I think. Somehow I was getting too many events by about a factor of 2. And I couldn't quite track down why this was happening. I think I just found a workaround in the code. I don't know if I ever really figured out exactly what was going on in the code. That was one of the more stressful moments. I think the other more stressful moment was I just had to find a random number generator that really was appropriate for the code, not really producing, just identical numbers of events constantly. And so I had to go through and find the best random number generator that I could, and I eventually found something that worked very well. But I know those 2 episodes in that code development were a little on the stressful side. I think the most fun that I had, uh, probably getting to meet a lot of the fellow researchers that we worked with at NASA Marshall Space Flight Center in Huntsville. That was really a great time. And then just seeing that this could actually be feasible, getting code finally worked out enough to where we knew what we were doing, and seeing that this was a workable concept out of that really surprised me the first time the initial instances of that were clear. So I think that was really the greatest thing out of all of this. But yeah, okay. Oh, okay. Here, who wants to go on next? Yeah, certainly.
Yeah, I was gonna mention if the next thing that we see is the SpaceX launch, I should mention when I was out in California, I had to stay up. Well, I mean, I slept and then woke up at 3 a.m. for a launch that occurred that day that I arrived. So that was cool. And it manifests as a big glowing orb on the horizon at night. And then you see a elongated streak of light in a camera because the camera does no justice to it. But that was pretty neat, and the delayed audio from the launch really sells how far away that was. And so, but besides that cool rocket launch, so the integration went so according to plan. Everything was so smooth and pre-planned that it really just felt like I was on vacation. Does feel nice to go travel for work and then only do about 2 hours of work. That's like just one plane flight.
Very productive 2 hours.
Yes. Technically, the people at ExoLaunch, they don't actually touch the satellite. All they do is set up the ramp, open the pod, and torque down the final screws and make sure the spring deploys correctly in the test to make sure that you fit the requirements. But me and the other collaborator, who also happens to be named Brian, out there in California, were the only people who touched the sat out there.
Right.
I hope this launches.
Of this 2.5-hour mission. Hello, everyone. My name is Zachary Lubin, and I'm an avionics supply chain engineer here at SpaceX. And I'm Nathan Commissary, a launch engineer here at SpaceX. At the very top of our stack, CAS 500-2 payload, or compact advanced based on Korea Aerospace Industry.
Over 30 missions.
Pressurizing for strong back retract.
And good news there.
This booster previously launched Transporter 14, Transporter 15, Bandwagon 2, along with several Starlink missions, just to name a few. And the Falcon 9 first stage makes up the bottom 2/3 of the vehicle and has 9 Merlin M1D engines at the bottom, which are capable of generating more than 1.7 million pounds of thrust.
About 2.5 minutes into flight, the first stage will separate and make its way back to Earth. Today, the booster is headed...
retract has started.
Today, the booster is headed to Landing Zone 4, or LZ4, at Vandenberg Space Force Base in California. With 4 minutes and 20 seconds to go, everything is still on track for launch.
And we just heard that call out that strong back retract has started, and you can see the clamp arms opening around the second stage there on your screen.
It'll take about 15 seconds for them to fully open, but once they're out of the way, the strong back will recline back away from the rocket to give it room for liftoff. Now that those clamp arms are fully open, the vehicle is fully free at the top. And you can see there that the launch tower's strong back is now moving away from Falcon 9, allowing it to stand freely before liftoff.
Right now, both stages are nearly fully loaded with about 1 million pounds of propellant. As noted earlier, that includes RP1, a highly refined kerosene, and liquid oxygen chilled to more than 300 degrees below zero.
Stage 1 LOX load is complete.
And there's that call out that stage 1 LOX loading is completed. Now you may have also noticed white clouds venting from the rocket, and those white clouds are not smoke, that is condensation. As the liquid oxygen warms slightly inside the tanks, some of it boils off. That gas is vented to manage pressure, and when the vented oxygen hits the warm and humid California air outside, it instantly condenses into clouds. Now, coming up shortly, we will be hearing a call out that stage 2 LOX loading is complete, and at that point, the Falcon 9 rocket will then be fully fueled. We should be hearing that call out in just about 15 seconds from now.
Stage 2 LOX load is complete.
And there's that call out that stage 2 LOX loading is completed. The Falcon 9 rocket is now fully fueled for today's mission. Now at the T-1 minute mark, Falcon 9 will be in startup, indicating that the vehicle's onboard flight computers will have taken over the launch countdown. And from that point onwards,
Ground
the rocket...
gas close up.
And from that point onwards, the rocket will be in full control. So we should be hearing that call out that Falcon 9 is in startup in just about 15 seconds from now.
Falcon 9 is in startup.
And there's that call out that Falcon 9 rocket is in startup, and the vehicle's flight computers have taken control of the count. Both stage 1 and stage 2 are now also pressurizing for launch. Now we're just waiting for the launch director.
For launch.
There it is. The launch director has given the final go for launch. So awesome news there. And we'll just sit back and wait for Falcon 9 to launch the CAS 500-2 mission.
T-minus 30 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff of Falcon 9. Go SpaceX, go CAS 502. Vehicle's pitching downrange. Stage 1 propulsion is nominal.
At T plus 30 seconds into flight, Falcon 9 has successfully lifted off from SLC-4E at Vandenberg Space Force Base in California. We're currently throttling the booster's engines down to prepare for max Q,
power and telemetry
the
nominal.
point of maximum aerodynamic stresses on the vehicle. Max Q is reached when the air density of the atmosphere decreases faster than the increasing speed of the rocket.
Falcon is supersonic.
And there's that call out for max Q.
Max Q.
There's the call out for max Q. From here on, even though the velocity is rapidly increasing, the atmospheric density is rapidly decreasing, resulting in less loads on Falcon 9.
And coming up shortly, we're going to have several events happening in rapid succession. In order, these are MECO, stage separation, stage 1 flip, second engine start or SES-1, the boost back burn, and fairing deploy. Main engine cutoff, or MECO, is where all 9 Merlin 1D engines shut down to slow the vehicle down in preparation for stage separation when the first and second stage separate. The stage 1 flip is when the booster turns itself around. We'll then see the boost back burn of the first stage, where the booster engines relight to send the booster back towards LZ4. And in parallel, the MVAC engine on the second stage will light, which will be called out as second engine start 1 or SES-1. Now, this engine burn lasting several minutes will propel the second stage and the payload to orbit. And then finally, we will see the payload fairings jettison away from the vehicle. Now, that's a lot of major milestones, and we should see that sequence of events start in just a couple moments.
MECO.
Separation confirmed.
MVAC ignition.
Stage 1 boost back startup.
And there we had that sequence of events. Next up will be the fairing separation, happening in just about 15 seconds from now.
Fairing separation confirmed.
And there you heard and saw those 6 events that happened back to back, including main engine cutoff, stage separation, stage 1 flip, second engine start 1, and the boost back burn and fairing separation. And that boost back burn is scheduled to conclude in a few seconds here.
Stage 1 boost back shutdown.
And right on cue, another engine cutoff on the booster and completion of that boost back burn. The next major milestone coming up is the entry burn on our Falcon 9 first stage, which is scheduled to occur at the 6-minute, 13-second mark. The entry burn is used to slow the first stage during atmospheric re-entry as it heads towards landing zone 4 at Vandenberg Space Force Base in California.
Now, we're currently in our first MVAC burn, which should last another few minutes, and you can see the MVAC engine there on the right-hand side of your screen. Now, today, the Falcon 9 booster, which is on the left-hand side of your screen, will be performing 3 burns in order to land. Now, we just observed the boost back burn, and as Nathan mentioned, next up will be the entry burn. Now, the entry burn slows the vehicle down just before it hits the denser parts of the Earth's atmosphere. And without this burn, we would only be using the atmospheric drag to slow down Falcon 9, which would add extra stress to the vehicle.
Now, following that entry burn, the booster will then initiate its final burn, the landing burn, to slow the vehicle's descent and allow for a soft touchdown on the landing zone. Now, when that Falcon 9 fires up the center M1D engine for re-entry, the vehicle will be flying through Merlin's exhaust gases, also known as the rocket's plume, which deposits a layer of soot on the vehicle's surface. And you have seen these marks across the flight-proven Falcon 9 first stage fleet. That soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little more on the outside of the vehicle. As we mentioned earlier, this booster, including today's flight, has flown over 30 times, and that awesome flight history also means that this booster has a substantially sooty exterior.
Now on our Falcon 9 booster, attached at the very top are 4 titanium hypersonic grid fins, and those help steer the first stage as it returns to Earth. And when the booster is on screen, you may also see white puffs coming off of the Falcon 9, and those are cold nitrogen gas thrusters, which aid in attitude control.
.306.
We are moments away from the beginning of that entry burn. You should see the graphics at the bottom of your screen light up as the engines do on the bottom of your screen. We're about 10 seconds away from that entry burn startup.
Stage 1 entry burn startup.
There's a call out for that entry burn startup on the Falcon 9 first stage. This burn is set to last only 11 seconds, and again, it's just slowing down the vehicle in preparations for its final burn.
Stage 1 entry burn shutdown.
And that concludes our entry burn.
Now, as mentioned earlier, we will be attempting to recover this booster, and today we'll be targeting a landing at Landing Zone 4 at Vandenberg. And you can follow along with the burn via the engine graphic at the bottom left-hand.
Stage 1 FTS is saved.
And good news there, you can follow along with the burn via the engine graphic at the bottom left-hand corner of your screen. Now, as this burn happens, you'll notice a decrease in both speed and altitude, as well as see which engines are being relit. And this is coming up in just about 15 seconds from now.
Stage 1 transonic.
I guess we missed it.
Stage 1 landing burn.
And there's that call out for landing burn start on the Falcon 9 first stage. And again, this is the final burn that the booster will perform for today's
Stage
mission.
1 landing leg deploy. Stage 1 landing confirmed.
And fantastic news there. Another successful landing of this
Stage 2 has entered terminal guidance.
Another successful landing of this Falcon 9 first stage.
Coming up next, we are expecting the shutdown of the second stage MVAC engine. This is known as Second Engine Cutoff 1 or SECO 1. This second engine cutoff is expected to happen in about 10 seconds from now.
Nominal orbit insertion.
And there's a successful cutoff of that second engine.
Stage 2 FTS is safe.
And confirmation of good orbit. And with that, we're going to take a break as the next major milestone, SES-2, where the Merlin vacuum engine on the second stage ignites for a second time, will be occurring at the T+54 minute and 8 second mark. So sit back, enjoy the views and the space shims, and we'll see you back here in about 40 minutes.
I hope everybody on Zoom was as excited as we were here in the room. That was pretty good so far.
John's right. I think it's a huge early one. Graduated. Bad for and a master's. So the next step is
Separation.
Masters.
I don't know actually. I thought that the separation of the
Preparing for the time being.
Oh, yeah, that's fine.
Yeah, whoever is still online can chat with us if they like. Then
I couldn't tell you
would,
without looking at
somebody.
Oh, okay.
iPhone, don't know who that is.
Numericals.
Yeah.
Yeah.
the web server is your website.
So yeah, about 10 minutes before 3 local time, we'll continue to tune into the live stream again.
It's still there though, right?
Yeah.
They'll just keep that this way.
Hopefully we are watching the live stream, but people on Zoom now see what we are doing. I don't know which one is more interesting. Probably actually that picture that doesn't change.
And we're gonna get there running. So I have to be in the area. Cool. That's our hosted. Oh, yeah. Oh, but we're gonna circulate. Yeah, I want to. I've been given these wrong. Oh, you're gonna give it down. Okay. Don't have to figure out what. No, we're okay. This one, I can't say what I do.
163 kilometers high, need to get to 500. Yep.
Well, they said it's gonna go to up to 8,000.
Okay. So
You have to circulate.
Right, yeah.
Remember the early days, they told us we couldn't go into a DTO orbit? I think if you ask now.
Yeah.
My role is to calculate the detector efficiency.
It would be just called picking it up, sort of like just before the second orbit. Spacecraft habits.
Yeah.
But they also told us, no, you can't be more than 3 kilograms if possible.
Right.
Nowadays, it's like 10 kilograms is fine.
Yeah. That's all good. Hello.
Congratulations on getting this far.
Well, it's up there.
Yeah.
Hope it survived one vibration test, it survived its temperature test, it survived its vacuum test. It should be good.
It's done everything in separation.
In separations, yeah.
And it's just fine, yeah. We are. You know, they display split into stage 1 and stage 2, and I had this nightmare scenario where suddenly I would have like 17 different objects.
Some of these other spacecrafts were going up with their not tiny little things.
Some of yes.
I mean, apart from the past 500, the SAR spacecraft and then thing is 4U by 4U by 4U.
Yeah,
It doesn't even have a launcher plate, it just has a launcher thing.
Yes.
Held down by flying out, but then the compression ring that when it releases.
Yeah, the original, yeah, you don't, no point in closing that using a separate container, yeah. Different layers for that.
The software full.
Honestly.
Now we wait.
Now we're waiting. I want to see our CubeSat kicked out.
Yes. I'm glad the coverage goes that long, you know, rather than saying. The fun parts.
Sure, yeah.
No, they do that.
That's all just. Maybe some people go to bed now, but every customer is going to wait around for.
I just sent you the first set of photos. Our space.
Yeah, we have it.
On the launch pad, like right before it got dark.
I so many songs.
And they sent us a group picture.
Applied mathematics, typically,
We don't have a 20 or
Oh, yeah. And then they sent us still on the launch pad.
In the physics track.
They'll be sending us soon the launch.
Very long time to see.
And the deployment video.
This is all included in your list.
Until he took over. Yeah, I did a lot.
Yeah, it must be nice to have, you know, a bit more of starting satellites to have fast internet comes there. Like
Right.
70% of the integration. I was there holding the camera and doing the miracles while he was working on it. So see that satellite go up.
I mean, they really did kind of do that.
So I'm still eating most Sundays, so well, we have the last week of.
You go on to mobile.
Yeah,
Yeah.
that's my favorite episode of the whole summer.
Oh, yeah.
It's like,
Oh,
yeah, that was my favorite. I love her. Like,
Oh, you're.
Yeah. But post like a hard second post or whatever else. Yeah.
Now we sit around and wait for our citizen science grant.
Oh, let's go. When came back, they just told me that. Yeah, I haven't changed.
Although the
white ones. My dad brought up.
Well, there's no way they're in a circular orbit. I mean, you would know it. It's only equal to that value. It's not. Well, there's got to be one out there.
Processing it. We're gonna. That's what. What I think we're working on simplicity. But also, probably exactly where actually I kind of enforce that a lot.
Oh, yeah, what information does he need? Yeah, yes, at a certain point. Yes. Isn't that all you need?
Yeah, right.
From the energy you can get. No, hold on, can't you get people?
Sure.
So you need to take over. But what do you need to get there a little better?
Yeah, sure.
So we just need to know that we really can't do this.
like what we need is for every updating and get a 5-minute window.
If I have the radius vector.
Yeah, and
Yeah, I know.
yeah.
Man,
We are giving a lot of extra space.
Yeah.
But like, here's some God information. But that,
I mean, maybe it's down here.
I've been mostly.
yeah, the control center knows the such a thing, but how we handle it.
And what we would do is, they're not updating it, we would get the speed now to 5 minutes later.
Yeah.
So.
Well,
We work as a group, so everybody has their fingers in everything.
Recording that helped,
But yeah, see, hardware and then. Setting up the
data analysis. But basically, yeah, like the altitude of the Earth change is like 100 kilometers over.
yeah, it was exciting.
Wow.
Yeah. And what was
Hey, John. Just want to say hi. I'm back. Going all right.
You know, I see the way some take after so the second that we might see if there's neighbors about what's basically just on space.
Yeah. Right there.
I'm just not used to it.
Yeah.
Is there anyone?
Okay. Yeah.
Oh, yeah.
Yeah.
I remember seeing a graphic and something showed you all these exaggerated. I never recall it 100.
Ah, there's Brooks.
I recall it being probably something like that. Showing his old brand.
Hey, Cameo.
You're on. Well, it may be just.
As exciting as this isn't easy.
Right.
Well, no, and this part is for transmission, but this one would be is just prototype to go on. We might have some background. But it is going to establish. It eventually the evidence is yeah, we don't really mind. This is right, so it's knowledge from side.
But also the. You gotta go through high school, you know, I was gonna say, yeah, this is what the technology is great right now. Wow.
You're right, no, it's been years. Yeah. Your name again?
Yeah, I don't know.
Oh, okay, yeah. You're. Thanks. Oh, yeah,
I was gonna say, I was playing.
Very perfect. You're, heck, I'm probably teaching physics labs. Yeah.
Yeah, it's good. Yeah, they taught him his, some things contacted you.
Well, I finished up a PhD. December.
Yeah.
And then after that, I came back up here and like doing.
It's been a scientific presentation. And most of those are the.
It's amazing ways of building in.
You'll see where it all takes me at this point, but in the meantime, just kind of,
Yeah.
like things studying.
I think I just might make another pot of coffee.
We got time.
Physics.
Got-
It's still physics, yeah.
I'll be back in a few.
Something, the space.
Look and block there. It's also a vending. Universities have lots of vending machines.
And, it also.
I hope this is good PR for the people who are reviewing our proposals. Communicate on the radio test.
So we're supposed to hear
Basically,
June,
UV,
so the window opens in about a month.
Yeah, which means it's in the hands of our folks.
That's the trouble, we don't get any feedback during this part of the press.
Oh, yeah. Well, I might.
It's like starting a race and not knowing how you're doing until the race is over.
That's right.
Go ahead and call, see if they're there right now. Need help,
I
man.
have
I was impressed they unlocked the building, okay.
Yeah,
I,
I was surprised too. I was coming up the door, I thought, oh, kind of late. There's not gonna be anybody out in the hall, and then, wait, doors unlocked.
We told them about this. They'll have someone stop by and check in. So they don't.
I would think so. Sounds like a cover story for nefarious activities.
It's been nice to see all. The velocity of that circle is. And we were basically gauge on the mass of the earth. Okay. Over R. You just got to so much the velocity of the over R minus over O. We have to put on velocity for everything so okay. Oh, awesome. As units of aerosols, we actually use mass as a units. And then I don't know, or we still seem to be what they call it, like man. They still call it eight limit. Yeah. Yeah, I know, yeah. I think they must have to have. So they do that same thing. Yeah. This stuff is nice. Love to see. I was it's physics, it's just. Well, physics always use the base now if you want to call it on mass. I don't get it about all this. Thanks for you want me to read the physics. I by start is my I'll talk about everything. Yeah, I know it's not only ever use paper assessment. Yeah. Insurance problems that they will never be. Depends. Yeah, because we don't have just the. There was during. So I'm on this board, you can ask for grants foundation. Space. And the founder of that organization just passed away. Right. And he has this business. It's already. Where you said having a he set up kind of the seed of that. Almost say, yeah. And it didn't go much further beyond that. I'd love to hear someone wants to stay. I'm going for Steve was in vision. Well, typically, you know, our serving with their bus. Space. Yeah, someone got that one. Like, what was I get this for organization? Yeah, just gonna be yes, but I mean, like, I would. So you put a big string on stuff. Okay. Yeah, I was like, I don't know what I think. Yeah, no, I didn't really get to know them all as a student, but it was later. And again, I do, frankly, I got to go into God's Zoom call with them.
Okay. It was a watch party, so I brought some chips.
Oh, there you go.
And I bought some butterscotch discs. And I brought some for the chips. I don't know if you want to do it or not.
Put it out. Thank people.
Okay.
Thank you.
I just don't want to see when he says watch party and I hear party, I'm like, I don't like coming to a party without doing something.
Well, that's why I brought donuts and making coffee. There's more coffee coming up soon.
Yes, I don't.
Yeah, Monday, Isn't that that's that? Oh, no. It's really close to that. Yeah, that's just a we calculated it. What's the circular velocity? Because I think it's going faster, but that's what I really want to know. Is it going faster than that? Is it definitely not with the circular velocity? It's got to be. Yes, I mean, but it hasn't updated the nothing. Whatever. It's only 15 of the papers to jump up, so 300 kilometers over the left hand. Circular velocity is 28,000. Well, a little bit faster. Yeah, it's a little faster. Yeah, so not far off.
I think they're not updating the hours per hour, so it's stuck at 130.
Like, what is that?
Daniel just recalculated it and he says, no, it's.
We can only have up there per second.
Yeah, I do.
I mean, before it stopped updating resources,
Yeah.
even if the BlackBerry changes, gonna be about the same.
Yeah.
Well, I guess they did.
Yeah, there may be a little.
They really don't want to see them down.
Yeah. I didn't see, I know there's an important comm satellite on Korean comm satellite.
Doesn't every satellite get tracked with a space every object?
They're very much.
You can find our optics already in the they're all information. Hopefully, it's just enforced.
Yeah, yeah, we're gonna be getting the number CAS 500-2J.
Okay.
And then we're supposed to claim our object in the space network tracking system and only once we're absolutely certain it's ours. Yeah, thought so too, but they didn't.
On the spy satellites, just like space debris object 327, like certainly it's not that easy.
Yeah.
But at the same time, you have to know about it.
Well, let's say that they were really fully classified as spy satellites, just don't tell you exactly what they do. They'll tell you they're there, they won't tell you exactly.
Oh, yeah. And what do you do?
Yeah, oh, yeah.
Like time your roof to like close whatever the spy satellites over there.
They pretty much do. They're so actually there's a funny story about that from back in the early days when they were working on the A-12 spy plane, they'd have these Russian Zenit satellites go over and program. They used infrared film on satellites. Well, pretty soon they got some intelligence saying, you know, the Russians are seeing what they're doing out there. And they literally gave them a paper to show the outline of the A-12. And they were like, how do they see us? Because we've been monitoring, you know, satellites going over, hiding this thing, you know, in the hangar. And well, what they figured out was that they had this radar test version on a pilot, and they'd send it out in the sun, you know, for a lot of the day. And then they bring it in, you know, when the satellites were going over. And it produced a shadow on the ground that cooled that area of the ground. And so the IR film on the satellite was able to pick up that pattern on the ground with the shadow. Now, the way they battled this was by pretty soon going out and taking these big flat cardboard cutouts and making all these fake patterns for this weird stuff, flying saucers and weird things like that to hide what they were doing. So they found a way around it. So it's like, okay, well.
They just can dump lots of ice on the runway.
Say again?
They can just dump lots of ice on the runway.
Cardboard cutouts, yeah.
That's when I feel like it's still there, the first people to know what the nuclear tests was for the last.
Oh, yeah, that's right. The film was getting off. Yeah.
It was destroyed. Yeah.
The US. Well,
Well, and there's the other thing, thanks for that, I tried to go through and reformulate all this film. Well, I don't know, there was one of those Starship tests where they played some like elevator jazz music. This one part of it.
Yeah, I was about to say, we know what elevator music is, now we know what space.
Why are there three different? Very different orbit paths.
Yeah.
I have no idea what they are plotting. I was wondering that myself. Actually, I asked what they what sense about what hardware you have.
Yeah.
So, you know, I bet some go there. I bet this is what I think that actually wasn't filming space there. It looks like it's going mostly around the earth.
Well, yeah, but then you've got that one, okay, you've got that one white effect of all the, you know, angles.
Yeah,
Oh, it's made two.
also they haven't made a full orbit yet, right? So it's like it's yeah.
Oh, they're about 80 minutes.
Just all three. Oh, our. So there, it's just. Right, so there's other two, like, that's when we've done whatever boost, that's engagements to go through.
One of my friends.
I did see it was going to work. Which is launch before.
Coffee's probably done by now.
So then, found out the answer from the school. During 20 years,
Only if they park in right next to the. Yeah, another company. Also. Yeah. If you want to go to the unloading. It's like that's a public. Parking like. The service. I think that's the salad case. I think. Oh, yeah. Yeah. Or. Yeah, that was very nice. Metal stuff. I was really happy. It is on that. Yes. You just
And it should be another 10 minutes to come back.
Yeah, yeah. Dustin's great. Like, it's switching on.
I need to know what words I say.
So it's saying stage.
Yeah. Just generic one, that's how I. Obviously, looking at the end. Yeah, I was like, no, that's actually the speed. That's what's going on. Well, we do lower radius, so there's no speed. There's no speed of light. Well, no, you can do it. How far over hour is it? Okay, Brian, have the video. The actual rocket. See this. It's about what it looked like when I was taught to the other one. Yeah, you can see them in from Los Angeles. That's right. Yeah, I was. Pretty good.
So this is a polar orbit.
Right. Yeah. Oh yeah. Polar. We aim directly south.
Oh.
Yeah, that's Antarctica.
Yeah, that's Antarctica.
Yeah.
Yeah. Ready?
I wonder where it's going to be passing over when the second stage, next second stage. Well, wait a minute. No, is there another run scheduled?
Yes, after circular
After circular, there's another second stage.
Then 2 minutes after the orbit, that orbital burn, the circle, it starts popping.
They start popping things out. So I wonder where it's going to be over when they do that next second stage burn, because I've seen one of those burns. Here on the ground, it's a really odd thing to look at. You see it's bright light, and then there's this little mist that kind of forms around the sky. When you see that go off, so be interesting to know who's going to see.
So apparently, the mist in Antarctica has developed a accent. There's a distinctive.
There's really
Yeah.
okay. I'll look this up. This center.
There was a SciShow video about it.
Oh.
Yeah, they apparently like 20 scientists.
Right.
Yeah. Naively, it's what, 70% chance for water?
Yeah.
But now I'm like, first 70 because I waited.
We don't know if this is actually updated correctly, right?
I think they've been updating its position. I don't think they've been doing speed rate.
Oh, okay.
Because I could believe that we've gone over Antarctica at this point.
Oh, okay. Oh, yeah, we should be over. That'd be real quick to get to Antarctica.
Yeah, we're at, I don't know, like we're 15 degrees right now, 15 degrees from south Fahrenheit. Yes.
It's close down to 30,000.
In the special ed class that I'm in, every morning we go through the phones with the kids and we'll talk about how it's gonna be today. And we just. Oh, yeah, 70 degrees.
Right. Brian says that a police car asking why London is doing in the street was scared out.
You see that rocket over there? Where'd the share button go?
Can't make it in. full screen maybe, just to see if it shows back up.
Audio. Video.
Maybe under more. Sure.
Why would they kill
I've heard that space is nice and warm, but there's coffee is down here like most.
At least the astronauts can have coffee.
I guess it's.
It don't bother me and it don't bother them.
All the donuts are. I'm like. What a waste, but also like. They're never like health. It's never like, oh, all this.
Now it's back down here. Why do they do it? Oh, this one.
I don't know.
Okay, we just wanted to share screen two, is that right?
Yeah, that blue.
Or is it this one?
You can either do the Google Chrome window or screen two with just that screen.
Oh, okay.
Yep. It's like what you give them an old person if you a tradition. And then as you grow older, each.
Oh, and somebody posted something in the chat. Oh, nothing interesting, nothing important.
Oh, yeah, just congratulations. Uh-huh. Okay.
As a view updated.
Does this mean we're going over Antarctica a second time now?
Yeah, it can't be right.
Well, it's blue here.
Yeah, but right.
I think so. Oh, that's the location of stage 3.
Yeah, so that's
Yeah.
But I don't know if that's projected directly or what that is.
Okay.
Right, that's about the right 90 minutes later, that's about how far Earth turns, so.
How do I get back? Why did they do this? Why, there was some information.
You can just close it, so you get.
The people with things like that. Yeah. But some other people are blue is protect. We just got done doing rubber Antarctica, now heading to the fastest ever got to it. Yeah, we're still at 163. Oh, there we go. Oh my God.
Well, it's about this. Yeah, 510 is our. We want 510. Let's go.
We're heading 523.
Oh, that's what we were.
Well, that's where that's 523. That's the mission. That's 500 and others. I like their first name. Let's just call it Transporter 16 and a half.
That's a good working name.
We sat there in 25th century AD.
Oh, it made sense.
We sat there and looked at the rockets from Mars.
It's sort of like the airplane. Sorry, we overbooked Transporter 16. Would you mind going on 16 and a half?
Technology
We're adding a new rocket.
caught up, didn't it?
Oh, here they come. recognize our butts. By the way, this is really interesting. During the launch, we had 50,000 views. Now he's gone up to 71,000.
Welcome back to our live coverage of the CAS 500-2 mission. And it's been a great launch and overall mission so far. We had an on-time liftoff at 12 a.m. Pacific time, and we recovered the first stage again, marking more than 30 successful landings of that booster. And now the MVAC engine on the second stage, which you see there on your screen, is preparing to reignite, and this is also known as SES-2. And that'll be coming up here at the T plus 54 minute and 8 second mark, and will only last about 3 seconds.
Nominal orbit insertion 2.
And there we have it, a successful SES-2 and a shutdown on the second stage engine. Next up is our primary payload deployment, which will begin in just a few minutes at T plus 59 minutes, 54 seconds. So we'll see you back here again shortly.
No, not more elevator music. I didn't even see it glow. Did you see the previous launch? There was this thing that just right where that big coil is, there was like this chem light or something. It flew out of nowhere and launched itself right there. If someone was cleaning it. Guess we're going to release at 514 kilometers. Oh, okay. You think so? No.
Welcome back, everybody, to our live coverage of the CAS 500-2 mission. We are moments away from the beginning of our primary payload deployment on today's mission. The CAS 500-2 is a high-resolution Earth observation satellite jointly led by the Korea Aerospace Administration and Ministry of Land, Infrastructure, and Transport. This satellite has been developed by the Korea Aerospace Industries and is equipped with an electro-optical payload designed to acquire high-resolution imagery to support a wide range of applications. Let's now watch as this payload is deployed in roughly 60 seconds.
Oh, we have to stop shot. Oh, there we go. Okay. Oh, it's a different view.
Those first class passengers get off first.
Looks like we're over Ethiopia.
And we've got an awesome view of our payload stack there on your screen. The second stage is currently flying over the eastern side of Africa.
We're about 24 seconds now away from the deployment of CAS 500-2.
How long would it take to get to Michigan and that's at a 14-hour drive?
CAS 500-2, separation confirmed.
Okay, they separated it somewhere.
And there's that confirmation of CAS 500-2 being deployed, and it is now on its way. But we still have another 44 payloads to deploy on tonight's mission. Now we have about 15 minutes before our next deployment sequence, so we're going to take another short break, and we'll be back around the T plus 1 hour and 12-minute mark.
1 hour, 12-minute mark. Will be the 9th one of the small satellites. So we don't have to wait till all the end. I'm hoping when it's actually no gravity that it's just flying up by itself, because we're not sending up there someone that's unpredictable. Oh, by the way, there's other snacks up here. More donuts. Help yourself. You got this. Got 12 more minutes. Someone brought in chips. Chips. Feel free. Well, we're supposed to be at 500 kilometers. 511's fine. We'll stay up there about 9 years instead of 7.5. Did you see the video of them launching that CubeSat from them?
No, I haven't.
It's very funny.
Set up.
Boom, boom, bang, right on you. Killed the cell in the solar panel. Yeah. What was the range they told us? It was going to be as high as 515 for us. As low as 490. It's okay. It's a good altitude. And I assume the big gap is to make sure none of the little CubeSats fit into the big spacecraft. Well, for the users, the deployment's the main part. For the public, it's the launch, and then everyone goes to bed. Yeah, but you had to get up the next morning and install the CubeSat. Yeah, we're just about to go over Turkey, everyone. Looks like the altitude's climbing there. Maybe it's not updated. Who knows? Yeah. Oh, you think it's a radar beam just going down to see how high you are? Oh, okay. We are recording, right, Paul? Well, the first CubeSat's going to be Selene. Then Cube 2. We're going to be number 10. Well, no, we're 10 on the list total, but we're number 9 of the small sat. What? Right, I was just wondering if that's just to make sure none of these little things hit into it, like they hit into the space station. No, they did. No, they did. It wasn't in view. Yep. Yeah, it looks like Romania, actually.
Welcome back, everybody, to our live launch coverage of the CAS 500-2 mission. Just before the break, we saw the first of 3 payload deployment sequences, with our second coming up here now at T plus 1 hour, 16 minutes, and 37 seconds. We've got a total of 19 separate payloads to deploy in this sequence, and here's a few of them. First up, the Hellenic Space Dawn mission, which includes 2 CubeSats, Ilios and Selene. These missions will demonstrate innovative space technologies for Earth observation and optical communications. Also integrated via ExoLaunch is Basalt 3, which will be the first privately launched satellite to be operated by LLMs and AI models.
We will also be deploying the Cube 2 satellite, Now, Cube 2, also integrated via ExoLaunch, will demonstrate the first ever quantum key exchange between a CubeSat and a ground station, laying the foundation for cost-effective, unhackable global communications. We will also be deploying FrontierSat, which is Calgary's first student-built satellite, which aims to study space ionospheric weather and perform novel technology demonstrations. And another payload integrated via ExoLaunch, Raven, is the first Icarus 2.0 satellite. Its mission will enable researchers to better understand animal movement and how ecosystems respond to change.
We'll also be deploying Unseen Labs' newest satellite, Bro-21, which is dedicated to the detection of radio frequency signals for maritime surveillance. Integrated via ExoLaunch, EnduroSat is the Balkan 2 Earth observation mission, designed as a fully managed Earth observation data delivery service to provide fast, high-quality optical satellite data. Also, Hydra 3, integrated via ExoLaunch, features a next-generation commercial multispectral thermal telescope.
We will also be deploying SNAPPY, an acronym for Solar Neutrino and Astro-Particle Physics, which is a NASA Innovative Advanced Concept funded project of Wichita State University.
Yeah.
And it will study the background rate of our planned solar neutrino detector signature. Also integrated via ExoLaunch, Gen 1, which is an S-band commercial communications mission with the platform provided by Orb Astro. We will also be deploying ICOR-1, which is Poland's first truly domestic developed X-band synthetic aperture radar satellite, enabling high-resolution Earth imaging regardless of weather conditions or time of day.
Now we're about to deploy these 11 payloads plus 8 more in just a few moments.
Yeah, there's other ones that you saw that important. AI powered quantum photography.
Getting some awesome views right now of our second stage of our Merlin vacuum engine.
Yeah, absolutely spectacular views here of our payload stacks on top of the second stage. The second stage is currently flying over Eastern Europe.
And we are now just under a minute from the start of that payload deployment sequence.
This is quite a view right now of all these payloads on top of our second stage.
Yep, 45 total for today.
Cube 2, deploy confirmed.
They can't put a gradient color image on those.
Here we go.
Deploy confirmed.
And our logo looks really nice.
Helios, deploy confirmed.
Just a shadow there.
Raven satellite for the Icarus Initiative, Talos, deploy confirmed. Brow 21, deploy confirmed.
That one with the new space, that one's ours. On the right. Yeah. Oh, we're in one of the Exo launches then? Yeah, we're in the.
Falcon 2, deploy confirmed.
But our logo will probably be in the middle.
Hydra 3, deploy confirmed.
But I can't see the, what is that one? God, what is new space? It's like perfect. Tagged alongside. There's a new soul vision.
SNAPPY, deploy confirmed.
Did you say SNAPPY deploy? There we went! Yeah! That thing flew out. Yeah! We had a good view. Whee!
It's amazing what the littlest prick can do when there isn't any air.
They did not want to go out on their uneven table over at space.
Yeah.
Gen 1 deploy confirmed.
Keep on the table.
Yeah, that thing just shot out of.
Yeah, don't blink.
Don't blink, yeah. And even looked like our CubeSat.
Link Tower 7 deploy confirmed.
Oh, there goes a big one. Wow.
That thing is good. Slowly.
That was wide.
That was big, yeah.
Basalt
Yeah, we
3
had a nice
deploy
view of our
confirmed.
little CubeSat. I don't know. You were slowing them in.
Expected LOS.
What's our updated two-line element? Where are we?
Now, the upcoming second half of this deploy sequence will happen without a downlink. So we're going to be standing by for the next several minutes while we wait for confirmation of the next several deploys. We'll see you back here in a little under 10 minutes.
That's great. Oh no. Oh no, now we got lots of, we have to register the CubeSat with the Space Force, but they said do it as soon as possible, but then they also sent an email, you know, if you don't get to it for a couple days, it's okay. Make sure it's your CubeSat.
Yeah, I mean, honestly, the first one down.
Yeah, it was a good one. Yeah, there was no end. You know, Holger was worried the antennas were would catch. Alrighty, everyone. I guess we're gonna stop sharing. We could call it quits. All right. Thanks, everyone online. Bye. We are in space.